Hello everyone! WeMol is a next-generation intelligent drug design platform independently developed by WeComput, leveraging artificial intelligence and computer-aided drug design technologies. It supports the design and computational simulation of various drug molecules, including antibodies, proteins, small molecules, nucleic acids, and peptides. WeMol features comprehensive functionality, advanced algorithms, proprietary intellectual property rights, and user-friendly operation. It offers advantages such as automation, visualization, low-code development, and scalability. Today we will mainly introduce the tools in WeMol's left sidebar menu. Log into WeMol. Click the icon in the upper right corner to switch between Chinese and English interfaces. Upon entering WeMol, the first thing we see is the navigation window. The navigation page categorizes and integrates commonly used functions based on user application scenarios. For example, in the Structure Prediction module, we have integrated the most cutting-edge open-source structure prediction tools, including a F2, Boltz2, Chi1, and others. Other features such as humanization, immunogenicity, affinity maturation, developability, and more. We have integrated all of these into the navigation panel for easy access. In the bottom right corner of the navigation page, it's a documentation button. Click it to display detailed descriptions of the corresponding modules in this feature. It also provides operation guides, instructional videos, and other materials for specific modules. The module interface in WeMol displays all functional modules. According to specific functional types, modules are categorized into different tabs such as protein, antibody, small molecule, peptide, nucleic acid, traditional Chinese medicine, and others. There are currently over 200 modules available, diverse and widely applicable. Based on this, we integrate different modules into application workflows and place them in the workflow. This enables users to submit specific computational projects with one click. Specific tags are also configured in the workflow. Some commonly used workflows, such as humanization, structure prediction, affinity maturation, molecular dynamics simulation, and other workflows. We placed it in the Feature tab. Additionally, we also created separate tags for biologics, small molecules, and molecular dynamics for easy user access and usage. There is a user-defined workflow functionality. Users can build new workflows according to their needs. Click the Add button to enter the workflow editing page. We can define the name of the new workflow in the name field, then build the specific workflow on the gray canvas in the middle. The left panel contains all the functions available in WeMol. You can search for the required modules in this section. We are adding a structure prediction module Boltz2, a PD preparing module, an interface analysis module, a PPI binding energy analysis module. When all modules are loaded, they will be connected in a pipeline. Drag and drop with the mouse to adjust module positions. You can define module input parameters in the right parameter panel. Starting from the second module, click the Upload button to find parent output. Once entered, you can select output results from parent or higher-level modules as input data for the current module. Please check the input data prompts to understand the required file types. After parameter configuration is complete, save the workflow. We can return to My Workflow to view and apply this workflow. In addition to creating your own new workflows, the existing public workflows in WeMol can also be edited and customized. Demonstrate using the Protein MD simulation workflow. Click to enter this workflow. Click the Save button in the upper right corner of the Submit and Run page. Go to the Workflow Editing page. For example, you need to add MMPBSA module to the workflow. We can search for the MMPBSA in the left toolbar. Drag and drop the module onto the canvas. Adjust the position and add connections between modules. You can right-click to delete any modules you don't need. Double-click to add a new module and define input parameters. When a module contains multiple methods, you can select the specific method you need. Use the output file path from the upstream module as the input parameter for MMPBSA. Other required parameters can be left blank if uncertain. Save settings. Modify the workflow name and save the workflow. The modified workflow can also be viewed and applied in My Workflow. Next, let's introduce the data page in WeMol. Upon entering the page, the first thing you see is Private Dataset. All files we upload and save to the data center are stored here. Click the Add button to upload files from your local device to this dataset. Click the Create button to generate new files. History files contain the input files submitted with tasks, as well as WESIC result files saved when running tasks in the sequence editor WESIC. Click on the developability prediction result file for the M35 antibody to jump to WESIC and view the specific result data for this task. The public dataset provides files from public databases. This includes representative antibody drugs collected by Adlamab, human antibody germline data, and public marketed drug databases. The Jobs section records our previously submitted or currently running tasks. We can add tags to different tasks as needed for easy categorization and searching. The Jobs section displays the created and completed times of tasks. Resource-intensive tasks require longer runtime, such as molecular dynamics simulations. The Tokens column shows the specific computational resources consumed by each task. We can also view different job statuses, including running, completed, canceled, and terminated. Click Advanced Options to quickly search for tasks. We can search for tasks by task ID, name, status, tags, time, and other criteria. Click to enter the task to view the specific task results. WeMol features an AI conversation function that allows direct interaction with an AI assistant to help users with coding, translation, text polishing, and other tasks. Users can also select different AI models according to their needs. In the bottom left corner of the WeMol interface, there's a daily check-in feature to claim computational resources. We welcome everyone to check in daily on the WeMol to receive free tokens. Also, there is an online documentation link. This documentation contains specific operational instructions for commonly used WeMol functions, organized into sections including visualization, biologics design, small molecule design, molecular simulation, and other features. It also includes frequently asked questions covering topics users care about, such as WeMol versions, data security, citations, and more. We encourage everyone to reference this documentation when using WeMol. That concludes today's video. Thank you for your support. We welcome you to try WeMol.